Scaling up development of a modular code base. That's a nice title, isn't it? So I also have some pretty pictures in my presentation and this neat presenter thing with which I can do animations. So I'll hopefully keep you a bit entertained for the next 30 minutes. So this works. Okay, so about myself, I'm Robert Munteanu. I work with Adobe in Bucharest, Romania on AEM. I am pretty close to the Jackrabbit and Sling projects. I'm a committer and PMC in both of those. Now, for our today's talk, I'm going to talk a bit about modular development, obviously. I'm going to break it down in what I see as sort of the 4 or 5 pillars of modular development. Source control, build, continuous integration, the IDE part, the development environment, and communication. So we've heard a lot about modular deployment, right? Ever since this whole microservices revolution, people have been now talking and realizing what modular deployment is. You can either do it with multiple applications or multiple processes, the microservices way, or by having multiple components or bundles in the OSGI way and deploy them into a single runtime, like we usually do with AEM. But we haven't really talked about modular development and how that interacts really with modular deployment. So first of all, we need to ask ourselves what actually is modular development. Do we do modular development? So if we have a single source repository where we store all our source code in Subversion, is that modular development, even though we do microservices? If we have a single Reactor build that generates all of our modules, is that modular development? So, yeah, no, obviously. The answer is no. We don't do modular development if we do that. But let's take things a bit slower and think about sort of a yes-no binary approach to this. So assume we have this axis and we have deployment here and development here, and say not modular, modular, and try to imagine how each combination looks like. So if you think that we don't do modular development and we don't do modular deployment, that to me sounds a bit like year 2000 PHP web application where you have the classes, the templates, the scripts, the CSS files, everything you have in a single repository, and from that single repository you generate a single deployable, whether that's a zip file that you unzip on the server or something like that. So that's not modular, not modular. Then you have the interesting scenario of doing not modular deployment, but modular development. A good example of this would be something like a Go application, because Go is statically linked in the end, and you get one binary. So you can have multiple libraries or utilities which are then in the end linked into a single application. And C can also do that, of course, if you're doing binary, if you're doing static linking. Now, this one which I sort of like to forget is modular deployment and not modular development. Now, that's where you have a single build and you generate multiple artifacts which are deployed independently. I would like to say that I never did this. Honestly, I never did this. But it's a pain in case I actually did this. So it's not something that I recommend. Now, the scenario which interests us most is modular development with modular deployment, because that's sort of where your development time and your deployment time, your runtime align. And we're going to see how a bit later on. Now, when I said let's do this a yes-no thing, it's not really a yes-no thing, right? It's like quality. Is my product quality yet? Whatever that means, yes, no. It's not that sort of question. It's, are you more modular on the development scale? How far are you along that scale? And the same goes for deployment. So you can think of it like a sort of a magical quadrant in which you have these two axes of modular development and modular deployment. Now, we start at the source with source control and try to ask ourselves, okay, what do we do with source control? So we have 50 deployables and we have one repository. Or do we have 50 deployables and we have 50 repositories? And interestingly enough, these days the focus is on Git and these distributed or decentralized source control tools. But there are many companies that go with single source control repositories and are very happy with them. They even have a brand new fancy name called monorepos. And I think I've heard talk about Google, about Twitter, about Facebook doing this kind of single source repository. So it's not a black or white thing. So let's see what the advantages of all of these are. So the single source repository has the major advantage that it's simple. It's simple for me to do an SVN checkout of the Sling repository, and I have all of the bundles in there. I can do aggregated searches over there. I can do, if I need, I can do a find replace on the whole repository if I want to do some code style changes or change a parent POM, or I don't know. There are many scenarios for doing batch changes, and then I can commit them into a single atomic commit back to the repository. So that's extremely, extremely simple. I don't need to jump through any hoops. What's not so easy with such a repository is, first of all, managing all the tags and branches. A couple of days ago, we had almost 1,500 branches and tags in the Sling repository. Okay, sure that they're, sorry, just tags. They are there, but they're not really easy to navigate. So, and branches as well, if you do a lot of branching, you also tend to sort of lose the navigability of branches. And then from an operations point of view, it becomes really hard. I mean, the more code you put into that, the harder it becomes to operate, to back up, to replicate, and to actually work at scale and performance. All the companies that are talking about monorepos are very heavily invested in tooling for those repositories, heavily either patching the tool itself or develop something from scratch, or completely repurposing another tool. So while monorepos can work in certain scenarios, and they can work very well, it takes a lot of investment to keep them going. Now, with multiple repositories, it's sort of the mirror image, right? So you don't have a single source checkout, but then they're small, they're navigable. And the tooling part, the good thing is that most of the time it's already built for you. So there's Bitbucket and GitHub and Stash and GitLab and all of these custom tooling, these products that are built, and people are building integrations and tools around them already. You don't have to start from scratch. Most of the time, 90% of the work is done. So you get those things for free that you'd have to provide yourself with a monorepo. So if you like that kind of distributed repository and you already have the tooling, I mean, the question is why not? Why not just use that? And speaking of these freely available tooling, there are a set of tools that would allow you to sort of remove the problem of not having a single unified view of the whole repository. Now, this is a tool called Repo. It was built initially for the Android software repository, and what it aims to do is create a way of working with multiple Git repositories in a single subdirectory. So it has a very nice, everybody loves XML in here, I suppose. So it has a very nice, beautiful XML listing which says, hey, this is a manifest, and then from the origin remote, take by default the revision name master. And then a listing of projects. This is the checkout project API to this path from this URL. And here I use a little trick, by the way. So we have this origin. So this is the origin, GitHub org manifest.git. So because I have this relative path, and the path for this project is actually /manifest/::, so going back one level, and then API Git. So all of these repositories here are relative to this org. Anyway, the point is that you can have a huge list. Say these are my projects. You can have paths. So you may want to have some sort of a folder structure, and then you can pull them with, you initialize the repo, check out, and then you sync, and all the projects are checked out or updated if that's needed. You have various branch management commands like, hey, start a feature branch for these projects, and you can script everything that's not available through repo by using this repo for all. So it solves the problem of having a single unified view. And going a bit ahead of myself, it's a very scriptable approach. So you can even have a build job in your continuous integration instance, which rebuilds this manifest based on some sort of API. Your SCM probably offers that, a way of inspecting the repositories and pushes it back to its own repo. So you can have this completely automated. Of course, it doesn't solve the problem of atomic commits. These are still independent Git repositories, and you cannot automatically, atomically commit to multiple Git repositories. But then I would argue that you don't really need that. You're 99.95% of the cases, you're fine with a series of pushes instead of a single push, unless you're doing trunk-based development, which is a completely different deal. So I was mentioning the automation here is a very short shell and readable, I think, shell script, which generates this XML boilerplate. So you have the preamble, the ending, and you do a little for each on a curl call on GitHub. Right now I have this experiment we're doing in Sling for converting Git repositories. So it goes to my home project and takes all the repositories, matching a certain name pattern, and then outputs the XML. So that's as easy as it gets with a little shell scripting. You can regenerate all of these, the whole manifest, without needing to do this by hand. Sometimes it happens that you need to take a big repository and split it into a small one. Now, I've had the experience of working with Git, and it was an absolute pleasure to work with a giant Git repository with a couple of hundred of bundles. And if, in case you're not yet painfully familiar with this, if you want to push a Git change, your local changes need to be at the same level with the remote changes, which is, yeah, okay, sort of a reasonable request from Git. Now, what happens is when you do a release with Maven, Maven creates some changes locally, right? And it tries to push them as part of the release process. And when you get 50 people doing that at the same time, what you get is a lot of yelling and cursing, even though they're not collocated. So I try to do a release, and I get a conflict. And okay, I pull, I start again, and if I'm lucky, I'm the one doing the release, not my colleague from the other office. So anyway, at some point you decide, okay, it's not such a hot idea to do a Git repository with a large number of projects. So okay, what are the tools that we have for sort of transforming a large repository into a small one? So you take a clone of the main repository, and you create a destination, right? So you take the local clone and create something like for the Sling engine bundle. And then you do something that the Victors do, which is rewrite history, to paraphrase a famous quote. So there's a very interesting command called git filter branch, which allows you to write everything. You can take a commit, you can take a commit message, you can alter it in any way that you see fit. And so you don't have to work too much. The Git developers added this subdirectory filter command, which reduces a Git repository to a single subdirectory, and even moves them at the top level for you, so you don't have to work. So that's perfect. You run this command, you clean up this refs, original refs, where Git stores for safety all the references. Otherwise, you get what I think is called a reference leak, like a memory leak in Java. You sort of have this reference chain in Git, much like you have object references in Java, and you have one single reference somewhere. Your repository will stay as big as bloated as it was before. So you do a cleanup, and then you're basically all set. All that remains is the original data in bundles engine. So in case you ever feel the need for that, you should know there's a pretty simple way of doing this. Now, I try to sneak in Greek symbols in all my presentations. I think it makes them look very intimidating and smart. Anyway, reactor builds or aggregate builds are something which is very convenient. In Maven, for instance, you can have a single POM XML file which lists 200 modules, and then you have a single command for building that repository. So what's the deal with this? So this is a very simplistic and simplified formula of reliability. So this is capital R for reliability, which I would state that is equal to the product of the individual reliabilities of its components. Or put it another way, the chain is as strong as its weakest link. Maven reactor builds are such components with a reliability. If you have 100 modules in your build and one of them fails 50% of the time, your build will fail 50% of the time. Your aggregate build will fail 50% of the time. So from a reliability point of view, it's not such a great idea to have a huge reactor build. So in Sling, we have something around 250 builds, and out of which a couple are failing and about 10 are unstable due to some failing tests. So basically we have a 95, 96% pass rate. Before splitting our reactor Jenkins job into multiple jobs, the job would be all of the time would be unstable or yellow because of those small number of modules. Now we get a much better impression of what happens with our builds because they are independent and modular and self-contained. So reactor builds are a bad idea. One, because they're not as reliable as individual builds. Two, because they greatly increase the feedback cycle. So instead of finding out in 4 or 5 minutes what your change did, you have to wait for a full build on the CA server, which can take 30 minutes, 50 minutes, depends how long all of the modules take to build. And it also consumes some resources on the server. And then you have the special class of bugs, which are reactor bugs, which happen only when you're doing reactor builds, which is extremely annoying to track down and reproduce. Now, if you decide to move away from reactor builds and create individual module builds, that's all fine and dandy, but as I mentioned, the reactor is convenient. And one thing which it does very well is resolve dependencies between modules in the same reactor. So you have module A and B, and A depends on B snapshot. When they build in the same reactor, you don't have to have B snapshot available anywhere. But if you have standalone individual builds, you need to provide that dependency somewhere. Either you have one single slave, which is okay, but will probably bite you later on, or you have multiple slaves and you change your Maven jobs to deploy the artifacts, the snapshot artifacts, and that's where this beautiful enterprise content repository comes in. So there are many artifact repositories on the market. There's Nexus and Archiva and Artifactory, so you can get whatever you choose, but when doing modular development, the artifact repository has a central place in your development process. And whenever you want to create a number of build jobs, you can either do this by clicking in the Jenkins UI, which is fine, but doesn't scale, or you can automate it. We discovered this artifact called the Jenkins Job DSL plugin, which is basically an artifact that executes some Jenkins, some Groovy DSL, and then generate jobs for you. So in the top part, you see we have some module definitions because we're not fully modularized yet. We have these artifacts in SVN, so just list them, which is fine for now. And then we basically do a glorified for loop where we say, hey, for each module, for each JDK, because we support multiple JDKs, let's define a Maven job. We give it a name, which is built from the job name and the JDK key, and then various Jenkins settings. You can see we deploy and we have the -u parameter because we want always to look for the most recent snapshots because we use the repository. And this has allowed us to very easily automate the creation and world management deletion of Jenkins jobs. Now we have the source control and the build set up, but we still need to probably make changes on the code, and ideally we'd use an ID for that. So there are two issues when going from a single project or a single checkout to multiple projects and checkouts. One is discoverability. You need to find, how do you find your projects? And B is, how do you ensure consistent formatting and other settings for your projects? As a disclaimer, I work mostly with Eclipse. I know almost nobody uses other development environments, but I just wanted to add this disclaimer that even though the tools are Eclipse specific, there are tools for IntelliJ and for NetBeans and for other IDEs that offer similar facilities. The point is to sort of realize that whether you need to do this or not. So for discoverability, enter Eclipse Oomph. Oomph is a project which sort of allows you to automate the provisioning of Eclipse instances, of Eclipse workspaces, importing of projects, global preferences, and it has this facility of creating a project catalog in which you can have various categories and projects and descriptions and keywords which help a lot when trying to import projects into your IDE. So that's one of the discoverability solutions. And yeah, of course, you can and should automate it if you decide to create such a project catalog. Now, the other part is configure your IDE in a similar way for each project or for each project set. I happen to work with multiple projects which have different ways of doing things. So Sling does things in a way, Felix does things in a way, Jackrabbit does things in a way, Adobe does things in another way. So global preferences don't really cut it for me. And the alternative approach that I've been taking is to take each ID preference and, if it's large, make it a Maven artifact and deploy it to that bucket of bits, to the artifact repository. And then pull it into my workspace and apply it with a plugin. Now, this plugin isn't yet public. I hope to make it public in the coming weeks. But the point is that you have your own formatter, which is a packaging artifact of type Eclipse formatter. And then you have a Maven plugin which looks for the Eclipse formatter you have in your dependencies and writes it into your local project settings. It's even not rocket science to write such a plugin. And if you integrate it with M2E, with the Maven Eclipse integration, you get to import your project. That plugin writes the settings at import time, and then your project is fully configured without you having to move a finger. And of course, if there are simpler configurations like the commit template for SVN or Git, or what kind of task reports to use, you could potentially add them as a plugin configuration as opposed to deploying an artifact, which is a bit more troublesome. Oh, wrong button, sorry. Okay, communication. Historically, there are two ways of doing this. You probably guessed it. One channel of communication or multiple channels of communication. Again, there are opinions on both sides, so I'll try to review both. Now, the way of thinking about a single channel of communication is that you have all your development technical communication into one place, and you maintain a set of tags and conventions when it comes to subjects so that people are able to quickly decide whether they're interested in something or not. This is an example from the OpenStack mailing list, and you can see that the usage of tags is pretty heavy. So if I'm interested in PTG, I'm not sure what that is, but anyway, I can just create a mailing list filter on PTG, and then the rest I can read whenever I have some downtime for the email, if I choose to do so. Now, the advantages are you have a single channel to subscribe to, which means I don't need to ask myself, are the right people on this channel? Do I get the right information just being on this single channel? Because I will. The downside is obviously that you need some more discipline and educating the people who subscribe to the list to use the proper tags and subject formatting. Now, the disadvantage is that without this discipline, it can become quite noisy, and people will sort of start ignoring it. Now, this is in reverse. You can have one or multiple channels per topic, which means that, well, you don't have a lot of noise because potentially not everybody is writing to the same single channel. So you have this sort of freedom to get into whatever, create whatever communication structure you desire. Of course, you have to make sure that you find the right people to get into that channel. So I usually find out about some important Slack channel whenever someone pulls me into that channel. I say, oh, so guys, we've been discussing this for a couple of weeks. It would have been nice if I would have known about that. Another problem is, well, I admit I cheated and took this screenshot from an older Slack channel. This doesn't really show you the number of channels because sometimes it can be discouraging, is the effort of not only initially subscribing to a set of channels because, hey, you do that, you get into an organization, you're a new hire. Okay, which are the channels that are interesting to me? But you have to know about the new channels that come in and decide every time whether you want to subscribe to a new channel. So that's something I confess I don't do. Right? I just don't sit around and looking for new interesting Slack channels to join. Yeah, so it seems that I'm sort of going for this one mailing list to rule them all concept, which is basically, I think that's the ideal setup with the note that you probably want to move noise, for whatever definition of noise is, to other channels. Now, I'm sure that whatever I do daily is very interesting, but I don't include my daily stand-up progress on the single communication mailing list. So if you find that your single communication channel is too crowded or too noisy, try to identify which items are actually noise and move them to side channels. But other than that, for us, single mailing lists have been working quite nicely. Now, wrapping all up, a reminder, it's not a binary thing. Is my development modular? Yes, no. I tried this completely non-scientific chart drawing of how modular are we with Sling. So in terms of communication, we think we're basically there, or I think we're basically there because I sort of decided how big the chart is. In terms of build and CI, we're pretty much fine. In terms of source control, we are probably not as modular as we want in terms of the repository, and we really haven't started discussing whether we want to do something in the IDE territory, but we're still standing still on that. So it's not a yes or no. But anyway, if you want to have a single takeaway from this talk, this is the essence, right? Scripts everywhere. If you have these big chunks, these big pieces in your development setup, which is your source control in the center, and then, by the way, the rectangles are things which others give to you. The round things are things which you write yourself. You will need to find the glue that links them together. So you can use the SCM APIs and the CI APIs, the continuous integration APIs, and automate your job creation. Your coding standards can be applied by the IDE and retrieved from the artifact repository. You can build a list of modules using the SCM APIs and then import them into IDEs. There's lots of little places, and as you saw in this, they're not huge, gigantic Java programs. They can be 10 lines of shell script, which really tie together those two systems and make your modular development story much easier to manage. Now, you'll have this in the slides. There are some supporting tools which we've used or we've seen used, and there are also examples of modular development being done. With that, I think I'm slightly over time, so I'll take a couple of questions. If there are any, otherwise, I'll be here for the full 3 days. Feel free to approach me.
If you're fine, it's okay. I said it's about 10 minutes late, but you started slightly later, so it's fine. You've got another 5 minutes, I guess. So if any questions are there, just state them right now. There's one here in the third row.
Hey, that's all nice and fine, but can you give a good example of an open source project that does this well?
Okay, we're doing this almost very well. So If you look at the, do we have a link? No, I don't have a link. If you look at the Sling CI stuff, right, we have 250 modules all generated manually. We don't, we take care of nothing by hand. Our Maven builds are very self-contained. Each module is built by itself. And we are doing, the problem with source control is that migration from Subversion to Git is not really that easy as I would have expected. Now, once we get that done, and hopefully within a week or two, we'll be able to make this area orange as well. So yeah, basically without trying to toot our own horn, we're pretty close.
Perfect. Thank you. Any other questions? There's one here in the front. Masood, could you just come here, third row? Yeah, that's perfect.
Hello. You just mentioned your tool. I think you said you didn't release it yet, which takes care about some IDE configuration. So what's the difference from OMF and this one? Because OMF can basically do all the stuff configuring already.
Yeah, that's a good question. So what I found out is that I sometimes need per project or per project set configurations. So as far as I understood it, OMF doesn't, it provides general preferences, but doesn't work that well when you have 1, 2, 3, 4 sets of project configurations.
Ah, yes, now, so you are getting like one Eclipse instance because OMF is for setting up, okay, so we just solved that by having one Eclipse instance per project, so
okay,
that solves us.
Okay, thank you. Any other questions? Here's one.
Hey, Robert. So when you talk about the IDE, the problem that you talked about in provisioning the projects and the editor config stuff, is there also not a problem around discoverability? So in Sling, it's 200 odd modules, right? I don't use Eclipse anymore, sorry. When I used Eclipse, though, I couldn't have a workspace with 250 projects at the same time. I had to have a works open at the same time, right? I could have, so I don't know how you do this, but I used to have all 200 projects in one workspace and then only open the ones I was interested in. But that was a huge pain to keep track of what I'm doing, and eventually would like have 50 projects open and have to go back and close them. How do you, I'm curious how you personally solve that, or how you think that should be solved, and how we'll solve it in the new Git world order or whatever.
Right. Yeah, so basically I threw hardware at it. So right now I can have 100 projects open. I think I tried with all 200 open. Anyway, I didn't necessarily need all 200 open, but I could have done that. What Oomph does in terms of discoverability is basically, this list of projects. But you basically have to know which projects you want to import. It helps if you want to generate the list and that says import all Sling projects, so that you don't have to import them all by hand. And in terms of management, yeah, maybe our laptops are now more powerful, maybe Eclipse is more efficient, but it sort of works.
Maybe I don't understand. What is it? What's on? Is this screen to install Eclipse or to provision projects in Eclipse?
It's to provision projects in Eclipse.
You just happen to take the screenshot from Eclipse because these are all Eclipse components?
Yes, because they're the ones.
They're the only ones using this, or the best example.
The best example.
Oh, okay.
Yes.
Then I misunderstood what this was. Never mind.
Okay.
Okay, thank you.